So for number 12, this is one of the rare cases where we have a parentheses and we're actually not going to let it equal what's in parentheses, meaning the substitution we're not going to have equal to x plus 4. I'm going to let it equal the more complicated thing. So I'm going to have it equal the denominator. So let's let u equal x squared plus 8x plus 2. Now, we do still have this x plus 4 up there that we do need to be concerned with, but let's keep going. So if I take the derivative, this is going to be 2x plus 8 dx, and somehow I need to get an x plus 4 here so that I can substitute it out. And it's actually not that hard, because if we just factor out a 2, du is equal to 2 x plus 4 dx. There's my x plus 4. So if I divide both sides by 2, 1/2 du is equal to x plus 4 dx. So again, this u substitution, my goal is to get all u's and du inside the integral. I don't want to see any x's. So somehow I need to do a substitution to accomplish this. And again, we have to take the derivative so that we can get rid of that dx. So the 1/4, or I should say 1 plus 4 dx is going to get replaced by this 1/2 du. So this does work out quite nicely. We will be looking at some ones where it doesn't work out so nicely. So this is going to be the integral of 1/2 du over u, which if we integrate is 1/2 ln of u plus c, which is 1/2 ln of x squared plus 8x plus 2 plus c. So that'll be our final answer.